This is a demonstration of the OptimEyes Blob Analysis Tool. In this demonstration, we'll analyze a picture of some pollen greens. With the image open, we'll launch the Blob Analysis Tool. Since the image was already open and active when we launched the tool, it's automatically selected as the input image. If it hadn't been, or if we wanted to use a different image, we could select it from the drop-down list or activate the desired image and then click the Input Image button. The Blob Analysis Tool gives us the option of selecting a mask image to use to find blobs, or to create a mask automatically during the blob finding operation. That's what we want to do, so we'll leave the Output Image field empty. Next, we'll open the Blob Options dialog. Here we can select the minimum and maximum sizes of blobs we want to find. We can indicate whether or not to find blobs that are touching the boundary of the image, whether to find blobs that are completely contained within another blob, and various other options. With our options set, we'll decide how to create the mask image. We can perform automatic thresholding, which sets threshold levels based on a selected percentage of the range of pixel brightnesses, or for more precise control, we can use manual thresholding, which is what we'll do. With manual thresholding selected, we'll move the sliders until the image looks the way we want it, with the things we want to be treated as blobs highlighted. With our threshold set, we'll click Find Blobs, and as you can see, the blobs in the image have been found. Each blob is a freehand ROI, or region of interest, that we can use just like any other ROI in OptimEyes. We'll click on a blob to activate it, and as you can see, it's highlighted in the list. This particular blob is blob number 0, the top one in the list, because we sorted the blobs by total area, and that's the largest blob. We could have sorted the blobs by other criteria, such as their X position in the image. We'll click Find Blobs again to clear the highlighting, and then, if we click blob 0, you can see that it's this one over here near the edge of the image. Blob number 1 is this little one, which is centered next closest to the right edge of the image. But let's go back to sorting by parent area. If I want to delete a blob, I can highlight it by right-clicking it, just like any other ROI, and then hit the Delete key on my keyboard. Any blobs that I delete are immediately removed from the blob list. With a blob selected, a variety of different statistics for that blob are displayed. For example, the area of the parent blob, the area of all its child blobs, along with its position, average gray value, and a bunch of other statistics. By default, size and position statistics are displayed in pixels, but if we had calibrated the image using the calibration tool, for example in inches or microns, all of the numbers would have been calculated in those calibrated units of measure. If we want to use any of these numbers we've calculated in Visualize Scripts, we'd go to the Parameter Options dialog, select the statistic we wish to use, click Generate VES Variable for selected parameter, edit the variable name if desired, and continue on for any other statistics that we wish to create VES variables for. With those options set, if we click Find Blobs again, the VES variables will be created. Each blob can be used just like any other ROI. For example, we could open the histogram tool, select a blob, and generate a histogram of its pixels. I'll scale the histogram to show the curve more clearly. Then I'll select some more blobs and add their histograms. Similarly, you could use the blobs with any other tool that uses ROIs. In this example, because of where we set the thresholding values when we found the blobs, this blob has no child blobs. Let's say we want to find child blobs inside this one by changing the thresholding values without losing the child blobs inside blob number 0. To do that, we'll delete this blob, draw a rectangular ROI around it, and then in our Blob Creation Options dialog, deselect Delete All Blobs from Group before finding new blobs. That way we can find blobs inside that rectangular ROI without losing the rest of the blobs in the image. Now we'll adjust our manual thresholding values so that the child blobs show up the way we want them. And when we click Find Blobs, you'll see that we found that blob again with its child blobs without losing all of the other blobs that we'd found in the image before. All of the blobs that we found are now listed together in the Blob Analysis Tool.